Caitlin, one of the youth librarians at Skokie Public Library, and joining me today is
Desi.
Today, we are excited to talk about one of the best parts of spring.
Daylight savings time?
Absolutely not. Although I do have some colorful words I could say about the experience of trying to pry two school-aged kids out of bed after we've sprung forward. In fact, I was thinking about rainbows.
Ooh, I love rainbows.
Everybody does. But did you ever wonder how they're made?
I assumed it was unicorn toots. Just kidding. It has to do with light, right?
It has everything to do with light. First of all, you have to know that white light, which is light from the sun or from a flashlight, is made up of waves of 7 colors.
Our friend Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet.
When those color waves are all together, they appear colorless. Cool?
Yep.
Okay, so you know that light waves travel in straight lines called rays, right? If those rays hit an object, one of 3 things can happen. They can be reflected.
When light hits an object and bounces off, it's called reflection. We see objects because light is bouncing or reflecting off of them.
Light reflects differently depending on the surface it's bouncing off. Think about the difference between the way that you see light on grass or the sidewalk as opposed to bouncing off a shiny car.
Gah, my eyes! This is because grass and other not shiny surfaces absorb some of the light's rays, so they don't appear as bright.
Finally, there's refraction.
That's where rainbows happen.
You mean the rainbow connection?
For lovers, dreamers, and science enthusiasts.
Yes. Okay, so we've got reflection.
Rays of light bouncing off surfaces.
And absorption.
Where objects soak up some of the rays, making them less intense.
And then there's refraction.
Here's where it gets interesting.
Oh yeah. So we know that light travels in a straight line until it hits something, then reflection or absorption, unless it hits something transparent. Then something really cool happens. Think about the ray of light traveling from its source, like the sun or a flashlight. It's all traveling at the same speed.
The speed of light.
Exactly, until it hits that transparent substance, and then its journey gets a little more complicated. Imagine you're walking down the street, minding your own business on a sunny day.
Easy.
Suddenly, you find yourself waist deep in a pool of syrup. There's no way around it. You have to walk through it.
Sticky.
Indeed, and also a lot harder to walk through. Do you think you'd be able to maintain the same speed as when you were walking unsyruped down the street?
Definitely not.
The same thing happens to light when it hits water. It's traveling along.
At the speed of light.
Then it hits water and slows down. You can actually see what that looks like by placing a straight object like a pencil or a straw in a clear glass of water. It looks exactly like you'd expect until it hits the water line, then...
Whoa! What the heck?
Exactly. The water is more dense than the air. You can tell when you're walking through water that it feels different.
So the light slows down as it moves through the water, making your object appear distorted. Very cool, but what does this have to do with rainbows?
A lot. Rainbows happen when light is refracted and then reflected. Do you remember back at the beginning of this conversation when we said that white light was made up of waves of all the colors of the rainbow?
Yes.
All those waves travel together really nicely until they hit that transparent substance, at which point they bend. But also, once they hit that substance, the waves move at slightly different speeds, which separates them. So if conditions are right, you can see each color wave separately.
We can actually demonstrate this in 2 different ways. The first experiment we did was with a flashlight and a glass of water. We used tape to narrow the focus of our beam, then shined it at an angle into the water until a rainbow appeared.
The next one we tried uses a mirror, a bowl of water, a flashlight, and a dark space. Position your mirror at an angle, then shine your flashlight onto it. Watch the walls for the rainbow.
Okay, I think I get this. But how does this work outside in the sky?
Pretty much the same, but way bigger.
So the sun is the flashlight and the raindrops are the water?
Exactly. The light entering the raindrops is refracted.
The color rays change directions.
And then the drops reflect all the colors.
Beautiful.
But you know what I always say.
Umbrellas are not toys.
And you are not Mary Poppins. And also, the best way to learn a new concept is through a catchy song. If you sing a catchy song,
You'll never get it wrong. Why are there so many moms who love rainbows?
'Cause rainbows are flippin' cool.
You might think they come from the farts of a unicorn.
But friend, that would make you a fool. Rainbows are light rays refracted in droplets, then reflected so colorfully. It's white light refraction, enhanced by reflection, then scattered so beautifully. Thanks for chasing rainbows with us today, junior physicists. We will see you next time.
Until then, be a rainbow in someone else's cloud.